Hi, today we are going to see baseline performance, rolled throughput yield. We will see today a traditional yield, first pass yield, rolled throughput yield, and the methods of calculations for each of these. Traditional yield. The formula for traditional yield is output by input. See, here is a process. The raw material input for 360 items are going inside the process, and 6 of them were scrapped and 354 of them were produced as output for sale. So what is the traditional yield? 354 by 360, right? But you ask a question, how many of them have been reworked in getting these 354 items? Because we have spent time, money, effort, all these things, no? Therefore, we have to consider all these things and then find out the efficiency correspondingly. So, we will ask a question, what is the rework? Without the rework, we know that 354 by 360 is 98% a good process performance. But is it so? Now here, the rework, they say it is 88 items. That means 6 of them have been scrapped, but out of the remaining items, 88 of them have been reworked. What does this mean? That means 88 items we have spent 2 times the manpower, time, and other things. Therefore, I must consider this also as not efficiently coming out. Therefore, consider it as a scrap. Don't consider in this output. Therefore, subtract this rework items, 88 items, from the output and then find out the first pass yield. That means output minus rework by input. That is, output is 354 minus 88. Therefore, if you use this traditional yield formula, it should be 266 by 360. That means 354 minus 88 divided by 360. That is the first pass yield. That is 74% only. As against 98%, we see that the efficiency is only 74%. Rolled throughput yield. First pass yield, you know, output minus rework divided by input. Now, if there are 4 processes, each process will have a first pass yield. So, first pass yield for the process 1 is 0.93. Similarly, for the process 2, it is 0.93. First pass yield for the process 3 is 0.99. And for the last process in the system, it is 0.98. Therefore, rolled throughput yield is nothing but the product of this first pass yield. As far as this is one step process, first pass yield and rolled throughput yield are same. Rolled throughput yield is equal to first pass yield. But when there are 2 processes in series, it is a product of 0.93 and 0.93, that is 0.865. Considering 3 processes, it will be FPY P1, FPY P2 into FPY P3. First pass yield for process 1 into process 2 into process 3. That is 0.856. And if you consider the 4th process, then it is 0.93 into 0.93 into 0.99 into 0.98, 0.84, 84%, right? 83.9 to be precise. So traditional yield is calculated using the formula output by input, where output is equal to input minus scrap. Therefore, traditional yield is input minus scrap by input. Example, input is given, output is given. Therefore, 354 by 360 is straight away you can calculate, or 360 minus 6 divided by 360. So 360 is the input, 354 is the output, 354 by 360 is 98.33. So we will see first pass yield. Output is equal to input minus scrap. So input is 360 minus 6 is 354. Rework is 88. Subtract that. So input minus scrap minus rework divided by input. 360 minus 6 minus 88 divided by 360. And you get 73.89%, because the net output is only 266, because 354 minus 88. We are having 4 processes. We will know how to calculate the first pass yield for the first process, second process, third process, fourth process. I'll tell you simple calculation is output minus rework divided by input. 698 minus 16 divided by 734 is the first pass yield for process 1. For the process 2, 655 minus 7 divided by 698. For process 3, 649 minus 3 divided by 655. Don't subtract scrap. 645 minus 10 divided by 649, because 645 is already obtained by subtracting 4 from the input. 649 minus 4 is 645. So we have the 4 processes here. We know how to calculate this first pass yield for all these processes by the method that I have told you, and multiply all these 4 and you will get 0.839. 83.9 is the answer. Now, if there are n steps in the process and first pass yield for process I, that is first pass yield in the ith step in the process, then rolled throughput yield is equal to RTY is equal to FPY process 1 into FPY process 2 up to FPY process n, where FPY process I is ith process first pass yield. So first pass yield for the entire system is input minus total scrapped minus total rework divided by input. But we don't consider the first pass yield for the entire systems. When there are more than one step, we consider rolled throughput yield. So traditional yield is input minus total scrap divided by input. Input also traditional yield also we don't consider, because that amounts to cheating. So here are the 4 processes. You can see that 698 minus 16 by 734 is 0.93. Similarly, 655 minus 7 by 698 is 0.93. 649 minus 3 by 645 is 0.99. 645 minus 10 by 649 is 0.98. Multiply all this and you will get the answer. 83.9%. Right? And traditional yield is obtained by the output 645 by 734. First pass yield for the entire system is calculated by total scrapped is, all this you add, 53, 59, 89. So this one is 10, 20, 36, right? So input 734 minus 36 minus 89 divided by 734 is the first pass yield for the entire system. But we do not consider this, as I told you. And rolled throughput yield is 0.839. We will see a case study. Vision Excellence conducted training for 20 green belts, out of which 15 passed in the first attempt. Further coaching was given to the students, that is remaining students obviously, and 4 of them cleared in the second attempt. What is the traditional first pass and rolled throughput yield in this case? Now once you draw the figure, you will be able to appreciate, understand very clearly. Purposely I am not showing the figure here, the values here. So option 1 is given here. Option 2 is given here. Option 3 is given here. What I will do is, I will write these numbers here. What is the input is 20, right? And then what is the output? Output is 15 of them passed and then 4 of them passed. Therefore total is 19, right? Only one is not passing, failing. Therefore scrap is 1, output is 19. How many of them attempted again? This is 5 of them. Because 20 minus 15 is 5 of them have done. Therefore, you can substitute and get the answer here. Traditional yield is 20 minus 1 divided by 20, 0.95. First pass yield is 19 minus 5 divided by 20, 0.7. Rolled throughput yield is not relevant here. Or you can say that rolled throughput yield and first pass yield both are same, because there is only one step, right? So RTY is irrelevant here. This option 3 is the correct answer. Case study 2. A shoe company manufactured pairs of different size shoes. Materials for 1000 pairs were supplied. Out of them, the quality team rejected 10 pairs as scrap. Out of the remaining pairs is 990. 60 pairs were sent for rework. Quality team inspected and found 50 of them were passed for sale, scrapping the rest. That is, only 10 were scrapped again. So what is the traditional first pass and rolled throughput yield in this case? So option 1 is given here, option 2 is given here, option 3 is given here. Here again it is only a first pass yield is relevant. RTY is irrelevant because there is only one step involved. I will show the figure here. 1000 input, 1000 pairs for the input, and 10 items were scrapped in the first stage, and then while reworking another 10 were scrapped. 60 of them were sent for rework, so another 10 were scrapped here, and therefore 10 plus 10, 20 is scrapped. Therefore output is 1000 minus 20 is 980. Therefore 980 by 1000 is the traditional yield, and first pass yield is 980 minus 60 by 1000, 0.92. So option 3 is the correct answer. Case study 3. A shoe company manufactured pairs of different size shoes. Materials for 1000 pairs were supplied. Out of them, the quality team rejected 5 pairs as scrap. Out of the remaining pairs, 60 pairs were sent for rework. Quality team inspected and found 45 of them were passed for sale, scrapping the rest. What is the traditional first pass and roll throughput yield in this case? Option 1. Traditional yield is 1000 minus 5 by 1000. No, the scrapped item is 5 pairs here and then 15 pairs here. Totally 20 pairs are scrapped. Therefore, it should be 1000 minus 20. Therefore, this is not correct. Option 2, yes, 1000 minus 20 by 1000 is okay. And first pass yield is 980, that is output, minus 60 were reworked. Therefore, 980 minus 60 by 1000 is equal to 92%. RTY is relevant because this is a one process with rework. See here, 1000 were sent, 5 were scrapped, 60 were reworked, and here 15 were scrapped. Therefore, the remaining is 1000 minus 20 is 980 is the output. So 980 minus 60 divided by 1000 is the first pass yield. Case study 4. A shoe company manufactured pairs of different size shoes. Materials for 1000 pairs were supplied. After inspection, 15 pairs were reworked. Output at the end of the process is 990. That means 10 items were scrapped. 10 scrapped, 15 reworked. So you will know how to find out first pass yield for step 1. The output pairs were sent for the final stage, that is second step, for curing. Here the 10 pairs were reworked and 5 pairs were scrapped. That means 990 minus 5 is 985 is the output. What is the traditional first pass and rolled throughput yield in this case? So here option 1, traditional yield is 985 by 1000, which is correct because 10 plus 5, 15, 5 is scrapped in the second stage, 10 were scrapped in the first stage. 1000 minus 990 is 10. So 1000 minus 15 by 1000 is 0.985. First pass yield is 990 minus 15 because 990 is output, 15 rework, 990 minus 15 by 1000 is okay. First pass yield for process 2 is 985 is output, we have seen, minus 10 were rework. So 985 minus 10 by input is 990. Therefore, that is also correct. And the product of these two is 0.96. Rolled throughput yield is 0.96. Therefore, option 1 is very correct. So option 2 is incorrect because here it is 1000 minus 15 I have used. No. Option 3 also here 985 minus 10 by 990 minus 15 I have used traditional yield, which is not correct. Therefore, 1000 minus 15 by 1000, 0.985 is the correct answer for traditional yield. Option 1 is the correct answer. Case study 5. In a process of inflating tires on scooters in an assembly, a study revealed that of 360 tires that went through tire inflation process during a day's production, 354 were later found to have pressure within the required specification. Tire after inflation is immediately inspected to ensure that it meets the required pressure specification limits. Inspection detected 94 tires that do not comply with pressure specification. The operators corrected out of 94 tires, 88 tires, leaving 6 tires that could not be brought back to specification and then scrapped. So what is the output? 360 minus 6, that is 354. That is what he says, 354 were later found to have pressure within the required specifications. So don't consider this as two processes, it's only one process. He is just giving the explanation for this 354 in this the later stage. So the operators corrected 88 tires, leaving 6 tires that could not be brought back to specification and then scrapped. Find the traditional and first pass yield. He is not asking you rolled throughput yield because it is not here. There is only one step. Traditional yield is output by input, input minus scrap by input. Input is 360, 6 is scrapped, so 354 by 360 is 98.33. First pass yield is output minus rework. How many of them were reworked? They have corrected 88 tires, leaving 6 tires that could not be. Therefore, 88 tires have been reworked, and so 360 minus 6 minus 88 by 360 is 74% is the correct answer. 73.88% precisely. We will see a quiz. Every process step will have a maximum and minimum yield. Yes, true. RTY is a measure of the overall process quality level. Yes, true. RTY summarizes DPMO data for a process yield. Yield means how many of them were defectives, how many of them were good quality. Therefore, it is also true. RTY by multiplying the DPMO of each process. No, it is false, because we don't multiply inefficiencies. We will have to multiply only efficiencies. Therefore, it is false. RTY is smaller than the lowest yield of any single process. Yes. RTY is a preferred yield calculation method over the first pass yield. Yes. As the number of process steps increase, RTY decreases, because we are going to multiply a number less than 1 only. Efficiencies will be less than 1. Therefore, it is true. I think that completes the quiz. Thank you very much for watching.